And we are live. Welcome to the Node Guardians YouTube channel, where we discuss all things blockchain, decentralized web, smart contract programming, and cryptography. It's a very interesting episode that we have here, as I'm welcoming Lumi, who's an independent researcher in the Web3 space, and another friend, Alex Smirnov, who's working on deBridge, an interoperability solution with some interesting standing out components. This is the first episode of a series that is going to cover all sorts of bridges, designs, architectures, and so on. And yeah, I propose you guys to share a small introduction about yourselves briefly, and then we'll start our deep dive into what deBridge is about and also explore bridges in general. So I don't know, Daniel, if you want to start, or Alex, but feel free to start, guys.
Cool. My name is Daniel Lumi. I'm an independent Web3 researcher and consultant. I work mainly on decentralizing provers, sequencers, and ZK systems, as well as how to do atomic composability between different fractal instances of ZK, how to prevent liquidity fragmentation in those instances, and how to shard gap space. That's the majority of what I'm working on right now.
Very happy to have you here. And how about you, Alex?
Yeah, hello everyone. My name is Alex. I'm CEO and co-founder at deBridge. I'm the developer and engineer myself. Have been in space since 2016. Was working on providing development services for different companies, and together with the team, we were developing different blockchain connected solutions and dApps. And yes, since the beginning of 2021, we've been fully focused on building deBridge, which is a cross-chain infrastructure that enables secure and seamless interoperability between various blockchain ecosystems. And yeah, excited to be here with you guys today.
Super cool. So I think that you've already shared a few words about what deBridge is, but could you give us a high-level introduction about deBridge, the way it functions, the standing out points of this design to the people who are not familiar with it?
Yeah, absolutely. So deBridge is, first of all, the generic messaging protocol. It's a cross-chain infrastructure. And in order to understand why we need bridges, we should first understand why interoperability is needed, right? Because blockchains by themselves are siloed or isolated environments, and there is a clear need to be able to transfer any information and value between different blockchain ecosystems. And that's why you can divide the whole interoperability problem into two parts. First, and the foundational one, is the transfer of message or information. And the second part is the transfer of value or liquidity. And the point here is that there is no way to efficiently solve the value transfer without having reliable and secure messaging. Because the only way to solve value transfer is to build it on top of messaging. And deBridge itself is the infrastructure that enables transfer of any information between different blockchain ecosystems. So we basically interconnect different blockchains to allow smart contracts to intercommunicate with each other. So because the main advantage of the DeFi space is composability, right? Money Legos can be built in a very different way, and that allows the protocols to plug into each other. And the composability works within one blockchain ecosystem, right? And that's what we call synchronous composability. When within one blockchain transaction, we can do a set of different transaction calls and interact with different protocols simultaneously. But on the cross-chain space, there is no way to build kind of composable money Legos, because the cross-chain space is asynchronous by default. And we cannot form different transactions within one blocks, right? That's why any cross-chain interactions consists of two parts, interaction on the source chain that initiates the message transfer, and then execution of this message on the destination chain. So there are two transactions involved. And deBridge itself is the infrastructure that enables smart contract to communicate with each other. So if smart contract or any on-chain address that can be externally owned account wants to send data to another chain, it can just call the send method of deBridge smart contract, and deBridge infrastructure will execute this message or deliver this message on the destination chain. So you can think about deBridge as about some kind of router, because I also like to provide this analogy that deBridge is some kind of Cloudflare for the internet of blockchains. Because when we interact with the Web2 apps, we just open the website, right? And we can focus on the application itself. When we interact, let's say, with Facebook, we never think what's the infrastructure is hosting the Facebook. We don't need to switch between like Amazon Web Services and Microsoft Azure. Everything is routed automatically. There are like load balancer, there are some routers, and it's all abstracted away from the end users. And in Web3 space, like we still have some kind of terrible user experience, because as a user, we need to know like what is the underlying blockchain. We need to switch wallets, we need to switch networks. User got to know what is gas price, gas limit, and then moreover, whenever the user is trading on chain, he also got to understand like how MEV works, like what is slippage tolerance, how to specify flashbots RPCs instead of like public mempool in order to avoid front running. And in deBridge, like one of our goals is like to solve these kind of technical challenges for the end users to facilitate the adoption. Because at the end of the day, like users should focus on the app itself. They shouldn't know like what is the underlying infrastructure, what is bridge. And we hope that like with deBridge, users will not need to use any bridges anymore. They will just be able to interact with the applications like directly. So yeah, and again, like if we talk about the kind of overall design, so deBridge itself is the generic messaging protocol, right? And it's non-canonical bridge. And by the word bridge here, I assume the technology that interconnects blockchains to transfer information, because again, the message transfer is the foundation of the interoperability. And then everything else can be built on top of this. Because like it's also very important to differentiate the canonical bridges from non-canonical bridges, right? Because canonical bridges can be trust minimized. That means that the canonical bridges can avoid consensus participants. They can validate consensus in a fully algorithmic way. And but the challenge of the canonical bridges is that they're not like user-friendly and scalable, and they mainly interconnect only two blockchain ecosystems, because the validation of the state through like light client or full client is like quite computationally expensive operation. But canonical bridges, like the main challenge that canonical bridges are solving is the asset custody. Because in the cross-chain space, like asset custody is the only task where risks are born continuously in time. Because let's say when we are bridging from Ethereum to Arbitrum, like you have assets locked in the smart contract on Ethereum, then you have the assets issued on Arbitrum, and these assets are locked. It's just like they're locked continuously in time, right? And that's why the risks are born continuously in time. And canonical bridges got to enable this trust minimization, so that like these assets are locked in a truly secure way. And that's why like asset custody is the main challenge solved by canonical bridges. At the same time, non-canonical or interoperability solutions are solving the message transfer or information transfer. That can be solved by canonical bridges as well, but like the idea of non-canonical ones is that they can interconnect any chains with each other and enable very fast and user-friendly transfer of information. And with message transfer, risks are actually distributed asynchronously, meaning that when we send the message cross-chain, as a sender, we bear the risk only during the short time period during which the settlement happens. Because let's say if I transfer some liquidity or like some message, as a user, I bear the risk from the moment when I initiate the message transfer until the moment my message is executed. And that's why the interoperability solutions should provide the best decentralization, not continuously in time, but during this short time period when settlement happens. And in deBridge, we're following this approach when we are saying like, look, guys, interoperability solutions cannot be trust minimized, because they got to have the validation participants, like the consensus layer. That's why all the bridges, like non-canonical bridges, have like validators or like Oracle and relayers or like watchdogs in case of optimistic approach. But these are some entities or some like companies who are like providing the infrastructure, and this is inevitable. And that's why absolutely all interoperability solutions are bearing the risk of collusion of these consensus participants. And in deBridge, our main goal is like to provide the best financial guarantees or like best insurance for any users who bear this risk during the message transfer. And we are saying that like absolute trust minimization is not possible for interoperability solutions, but what we can achieve here is to provide the best financial guarantees. Because let's say if as a user, I want to transfer some big amount of value, let's say like $100 million, right? And the total collateral of all validators, like kind of stake of the validation layer is $50 million, then I just need to split my transaction into two parts to make sure that each part is covered or like insured by the collateral of validators. And as a user, I only bear the risk from the moment I initiate the transfer until the moment the transfer is fulfilled. And I don't need to care about like the wrapped assets or like how the asset is custody, because when I do the transfer, I already know what asset I want to receive, right? I just like specify the token address of the asset. And I assume that the problem of custody is already solved somehow. And most likely it's solved by canonical bridge. But interoperability solutions use like to enable this seamless interaction and transfer like information value between chains. So yeah, and that's like the vision that we have in deBridge, that like there is no way to achieve like trust minimization, absolute trust minimization, but there is the way to provide the best financial guarantees for all the users. And in terms of bridging, like one of the main verticals on how to compare different bridges is like the scalability and how this validation layer is designed. And yeah, that's like how we see the space in terms of like message transfers. And yeah, DLN is like different part of the story. It solves like for the cross-chain liquidity transition.
We'll get to deep dive into this a little bit later. So in layman's term, this is a non-canonical bridge with a general message passing interface that goes through an off-chain system, a set of validators that has the responsibility of transferring a message from chain A to chain B. And so that comes with trust assumptions, which are not like denying. And the idea is that you have a set of smart contracts that are deployed on all the chains that you're basically interconnecting. And people are just like submitting a payload, like they're calling these contracts in order to send a message or any kind of transaction whatsoever. There's a hash that is associated with that call, I guess. And validators have to pick that signal. They keep on like fetching and fetching and fetching what's going on in each chains, and they sign that message. All of them have to basically like agree that this message exists and that it has to go there. And I'm just not sure whether you have defined deBridge in its current state or what is going to happen with DLN. And that, yeah, with that message, there could be a set of market makers in the target chain that will basically settle the order. But anyway, I assume that this is an architecture that has a lot of similarities with existing bridges, the committee like validator-based bridges. And if I want to build composable applications as a developer, I can just call that contract, or there is some kind of development kit that's available to build composable applications out of the deBridge infrastructure. You confirm that?
Yeah, exactly. So yeah, that's how actually all the interoperability solutions are designed. There is like two layers. There is a protocol layer, which is represented by the set of smart contracts deployed in every blockchain that is supported by the deBridge, for example. And then there is an infrastructure layer. And infrastructure layer is represented by the set of consensus participants that can be, again, validators like oracles and relayers, or like watchdogs, whatever. But these consensus participants are validating the information. And in our case, whenever there is a message that has been transferred, like validators are tracking the message that is passed through the deBridge smart contract, and every single validator is obliged to sign the message. So validators produce the signature, right? And like the design of the validation layer is one of the main verticals on how the interoperability solutions are compared, right? Because again, like all these solutions are bearing the risk of the collusion of the validators. And that's why like the users or the consumers of the infrastructure should be confident that like validators will never forge the message and deduct like liquidity from the protocol that is integrating with the interoperability solution. So yeah, in our case, we've taken quite a unique approach in terms of how we designed the validation layer. Because in deBridge, we have off-chain validation. We have the set of validators who are elected by deBridge governance and who work for deBridge governance. And validators actually like provide the infrastructure. They run the deBridge node together with the full node of every blockchain that we support. But it's important to understand that like in deBridge, we don't have our own blockchain. And we truly believe that like blockchains are not needed for interoperability solutions. Because like, why do you need your own blockchain if you still need to settle consensus on the destination chain? Then the intermediary blockchain would be some kind of bottleneck in terms of throughput and additional attack surface for the interoperability layer.
Very inefficient database.
Exactly. Yeah, because like you send the message, you initiate it in the source chain, you should execute it on the destination chain. Like, why do you need to have like intermediary inefficient database for this? And I know like there are many solutions that are built like on top of Tendermint that are using like Cosmos SDK, but I don't think that this is like the most efficient solution, because in deBridge, like we have off-chain validation, which gives like a few very fundamental advantages. First is the scalability. So our validators are doing one simple thing. They produce cryptographic signature. So you send the message, validators sign this message, and then anyone who has signatures from validators can deliver the message and execute transaction on the destination chain. So the goal of validators is only to produce the signature and then make the signature public. And to make it public, they can use the data availability layers such as IPFS or RVIF. So actually now with the new update of deBridge node, like all validators are storing the signature into bundler, which is like the solution built on top of RVIF. And then anyone can retrieve signatures from RVIF and execute or deliver message from the destination chain. And this kind of design provides us with the unlimited scalability feature, because we are not limited in terms of throughput. And I would say deBridge right now is the only infrastructure that has unlimited throughput. So we can produce we can verify or validate more transactions than like Solana and EVM chains altogether, simply because this operation happens like off-chain. And unlimited throughput and scalability is the first thing. Second one is the security, because validators, in case of deBridge, they never talk to each other. Like we don't have networking at all. They don't talk to each other, and like nobody knows where validators are running the infrastructure. That's why it's very possible to attack, because like we've seen a few attacks, let's say Ronin breach, where like the infrastructure was compromised because the attacker somehow managed to get access to the servers. Right. In our case, like even we, like as a core team, we never know like where our validators run the node. And some from Node Guardians is one of the validators in deBridge, and yeah, we're very excited to have you guys with us as well. But like validators are like those who are kind of securing the protocol. And if they don't talk to each other, if they don't broadcast transactions, then there is no way to attack the infrastructure.
Socially, I can talk to some people. I can to some other validators. Yes. The machine doesn't have networking with the other validators, maybe, but I can talk with some other validators, right?
Yeah, yes. And you can try to collude, right? You can like say, look, guys, here's like the transfer. We can try to forge the message and like kind of withdraw the liquidity from this transfer or value from this message. But in this case, you will get slashed. So our goal is also like, we have this delegated staking and slashing module. We haven't launched it yet, but we'll launch it shortly after the TG. And that module actually the one that kind of provides the financial insurance, like financial collateral of validators. So if the validators are doing something wrong and they forge the message or they censor the message, they get slashed by deBridge token holders, by governance. And any party that had like a financial loss due to misbehavior of validators will be compensated. And that's like the analogy that I told before, like with the example when I transfer like $100 million, when I can like where I can split transaction into few parts to make sure that each part is covered by the collateral. But yeah, so security is the second part. And the third one, which is very important, is the gas efficiency. Because in many solutions, like validators are relaying the transaction, right? They got to broadcast transaction on the destination chain. And here we have the problem with the guaranteed finality, because validators should validate transaction only after it's achieved finality on the source chain. And all the chains have like different finality requirements. Let's say for Polygon, that's like 256 blocks, which is like 15 minutes time interval. And when senders send the message, the gas price
for a good reason too, because the reorgs by 200 blocks regularly.
Yeah, we've seen some reorgs on Polygon recently, yeah, and they were all quite big ones.
Yeah.
And with bridging solution where validators broadcast transactions, validators or consensus participants bear the risk of gas price volatility. And at the end of the day, this risk should be covered by the message sender. That's why many of the existing interoperability solutions are not gas efficient, because they got to kind of relay every single transaction and accommodate that risk of the gas price fluctuation. So in our case, validators never broadcast anything. And if you click on the address of deBridge validator, you will not see any transactions on the chain, right? Because they use their address only to produce the cryptographic signature. And the message itself is can be delivered by anyone. Anyone can be keeper or relayer, and that can be the user itself. And if the user has not passed enough gas, or we call it included gas fee, which is incentive for relayer to execute transaction, then the user will have to claim the transaction by himself. But again, with this design, we provide very high level of gas efficiency, because if validators don't need to bear gas cost, then the message sender does not need to bear gas cost. And that's one of the other verticals on how to compare the messaging protocol. So again, to sum up, the three main verticals are scalability and throughput. Second is security and how the validation layer is designed, and third is the gas efficiency. And
if I pick apart some of those points of first of all, I want to give you guys props for the fact that you're pushing for native assets on chain. So there's essentially two types of bridges among the many categories of bridges, which is wrapped asset bridges and then liquidity provider bridges, where you can send ETH from Ethereum to Solana, right? That would be a wrapped version, but you can send USDC, native Ethereum USDC to native Solana USDC, or Ethereum to Solana. So you do a swap during the transaction. So first of all, I want to give you guys props for carrying that torch. Keep carrying it, bro. This is, when we do cross-chain transfers, we should try to stay in native assets as much as possible as users to minimize our own risk. There are always these problems that, like you said, no cross-chain bridge is fully trustless, whether it's the validator committee or wrapped assets is actually a huge one. So for the validator, you mentioned the fact that each validator has to post a bond, right? And there's always this sort of capital efficiency and economic security question of how much should validators post bond, right? And I'm personally an advocate for one-to-one. They're not allowed to transfer more than they're bridging, but that's something that maybe validators aren't willing to do because maybe they don't have $100 million to lock in, right? So the question that I'd have for you on that specific part before we moved on to the third part is, how much do validators currently post as collateral, and how does that limit their ability to actually send a specific amount of funds?
Yeah, that's a good question. So as I mentioned, so far in our case, in case of deBridge, validators don't bear financial risks because we haven't launched the delegated staking and slashing module yet. And it will be launched after we introduce the token, after the TG. So right now, the users of deBridge infrastructure assume that validators will not collude, right? And if they collude, user will not be reimbursed. But again, we work with very professional infrastructure providers, Nodes Guardians, StakeDAO, staking, and many other guys who are validating many chains. So there are two components here. Validators bear two risks. First is the reputational one, and the second is financial. So right now, at this stage in deBridge, they bear on the reputational risk because the path to this decentralization should be iterative, right? There is no absolute decentralization or instant decentralization. It's just very important to gradually move toward more and more decentralized structure of the protocol. And we started from bootstrapping the ecosystem by setting the set of experienced validators, because we actually picked validators based on their performance in deBridge testnet that we launched back in November 2021. And we picked 12 validators out of more than 30 based on their performance, their uptime, and overall reliability. And we're super satisfied by the current set of validators. And again, big shout out to all the infrastructure providers, because like so far we have like 100% of the uptime and 100% of the message deliverability. Like many interoperability solutions and bridges had different problems in terms of like uptime and like hacks, like security incidents. In deBridge, we've never had a single problem. Like since the mainnet launch that happened like 17th of February last year, we never had a single issue. And part of the success of this is like the great performance of the validators who are like really professional infrastructure providers. But again, as soon as we have token, we'll have the delegated staking and slashing mechanics where
So
validators.
that's an interesting, like, how much have you guys done investigation on the capital efficiency side of how much should a delegator actually post? What size transfers are they allowed to do? And then as a separate but related part of your guys' delegated post model is that either the validator can put up their own bond or users can delegate bond to them, which to me is a bit risky because then they're not playing with their own money. Then they're putting someone else's money as bond, which might reduce the incentive. So again, like I'm kind of curious about the percentages of like how much does the validator need to put up, how much are they allowed to take by delegates, and then how much are they allowed to transfer with that amount of money?
Yeah, you raised a very good point actually, and the answer here that like the economy should be very efficient. It's very important to create a feedback loop, right? So in deBridge, like this delegated staking and slashing module is designed in a way that half of all protocol fees goes to validators and those who delegate liquidity for them. Because if you delegate liquidity for validators, let's say not guardians, then you participate in the protocol fee distribution mechanism. So the more transaction we'll have in deBridge infrastructure, like the more messages are sent through our protocol, the bigger profit of the validators is. And then this profit is distributed evenly between all the validators. So let's say if we generate like $100,000 in transaction profit and we have 10 validators, then every validator receives like 10,000, right? And then these 10,000 are distributed proportionally between the stake of all delegators. And validators can be their own delegators. I mean, they can stake for themselves. And that's, in this case, they kind of showcase that they take the validation seriously and they also bear their own financial risks. Some validators can say, look, we have zero stake, but we bring liquidity from other delegators, right? In this case, validator does not bear, still does not bear financial risk. But what happens is that there will be another validator that will say, like, look, guys, I want to nominate myself as a validator in deBridge, and I want to post like $10 million of my personal collateral, like staked for myself. And then the protocol governance will rotate the validator that has zero personal collateral by the validator that posted 10 million of the personal collateral, because like the governance will tend to pick the validators who also bear their own financial risk. That's how it's solved, because we
there's some kind of concurrency. There is a race to the one that is able to supply the most of its own capital to get the biggest opportunity, which to some extent, like it makes sense, but it's not a good thing, right?
Yeah, why it's not good? I mean, it also depends. It doesn't mean that like every single validator will be chasing like the maximal personal collateral. You can have just like certain amount just to showcase to users, to your delegators, that you also like take this seriously. Because if you have zero personal collateral, then delegators will not be willing to stake for your validation node, right? And here it's also very important to understand like what assets are staked, right? Because in case of deBridge, the two main assets are ETH, like Ethereum, and the stable coin, like USDC or USDT. And then the third asset, there will be opportunity to stake the deBridge token, right? But that like third component will be capped, because we truly believe that it's very important to limit the correlation between the collateral of validators and the performance of the protocol. And that's actually one of the big problems of the Tendermint-based solutions, because you can actually attack most of them in a sense that you can buy the governance token, then you can start rotating validator set in case you have a big stake. And you can also hedge the cost of attack by opening the short position on perpetual market, right? So you acquire a big chunk of the tokens, let's say like 70% or like 70% of stake tokens or something like that. Then you open the short position on perpetual markets, and you start to attack the protocol by putting your own validators instead of like the one that were there before, because you have like a big stake. And you already like, you can withdraw the like liquidity, forge messages at the same time. You already hedge the cost of attack. And that's why I truly believe that like tender mint based solutions are not very efficient for the cross-chain interoperability. And that's why it's very important to have the financial liability of the validation layer to be not correlated with the governance token. So there should be some kind of stablecoin component or Ethereum, because like even if something happens with the protocol, like the collateral of validators will not shrink, it will not reduce, it will be on the same level, and the financial kind of liability of validators will be the same. And that's why we also will tend to cap the deBridge token component in the delegated staking and slashing module to make sure that like it's not correlated, but with the not correlated with the protocol performance. But again, this like we need to create the closed loop economy, right? So the more fees the protocol generates, the bigger APY of validators is, and that means the more users will be able to stake for validators. And that creates an interesting economy, because like the more activity we have, the more financial guarantees we provide, right? And that's quite interesting mechanics. And that's why also in deBridge we build like the value transfer protocol, like DLN, under the same umbrella, because like so far the cross-chain value transfer is still like one of the main consumers of the cross-chain messaging. And that's why it's important to inject the profit that is generated from the value transfer transactions into the infrastructure itself, so that the more volume, like trading volume, the value transfer protocol process, the bigger financial guarantee of the messaging infrastructure is. So yeah, that's how like we are solving.
So that's actually an interesting point. And just to ask a little bit of a spicy question there, like I always ask, like you'll never hear when token out of my mouth. You will hear why token, right? And I give projects a hard time for tokens because, well, honestly, we have a lot of very useless tokens, and I know we need to issue these to be able to raise funds. But that's actually an interesting economic attack that you mentioned of like, so you guys actually do cap the amount of delegations that each validator can get? Because in a similar way to the IBC module, someone could take a short on the deBridge token, buy a bunch of it, delegate it to themselves, capture 4 of 7 of the validators over time, and then short the shit out of the token and essentially attack the protocol, steal the funds, and then they don't lose money on the deBridge token because their short covers that loss.
Exactly. So yeah, we cover the deBridge token part in the total collateral, but at the same time, you can stake any ETH and USDC for a specific validator. So there is no cap here, right? But at the same time, in terms of the token, like even if you acquire the big chunk of token, you'll not be able to rotate nodes, because like in order to rotate validators, you should make the governance proposal, and governance proposal should pass voting period, right? And if you make proposal to rotate like 12 validators, let's say, to your own nodes, then everybody will be already aware that there is the proposal in existence. And like if this proposal will pass for some reason, like everybody will stop using the infrastructure in advance, right? And that's why like it's also important to have like decentralized token distribution. But like even if somebody managed to acquire big chunk of tokens to vote for a specific proposal, like everybody will know about that in advance. So there won't be any risk for the like consumers of the infrastructure or for the end users.
It's some form of circuit breaker through the consensus of validators.
It's in a way, these are hard problems in cross-chain bridging. Don't get me wrong, like I am based in the ETH ecosystem, and I try to build trustless bridges for protocols, including between fractal instances. But I do think that we definitely need the cross-chain bridges, because the reality is not every single application has the same security requirements, and blockchains in their current design don't really scale. So we do have and will have different cross-chain bridges, but I also think it's really important for us to make sure that these are extra secure and that the users don't have to be aware of the risk, or by designing the best systems that we can. So again, just to push on this a bit more, and I'm sorry for pushing a lot on this, it's like validators in any bridge, in any cross-chain bridge, becomes the #1 security issue after just bugs, right? Or smart contract exploits. So let's say that I'm a validator and I collude with a couple of validators. We buy a lot of deBridge token, and then we stake it to ourselves, and we can do this slowly over time. And then we can start stealing transfers for like as much as we can in a day, short our position in the token itself to cover that. And then we can steal funds and make money off of, or at least back our deBridge token. So will you guys have like some limit of 50% has to be USDC or ETH, or like something that is not directly correlated with the pricing of that bridge? Because if the bridge gets attacked, the token dumps, right?
So 2 attack vectors that you touch. First is the attack on governance, and the second is attack on the consensus algorithm, right? If you're a validator and you want to collude with other validators, you don't need to acquire the tokens. You just need to acquire kind of agreement with 2/3 of all validators. So let's say we have 12 validators in total, like we have now, and you're a validator that wants to do something wrong, then you need to find 7 other validators who will forge the same message together with you, right? And when you do that, you'll immediately get slashed by governance. So that case will be tracked. The governance of the protocol will create a proposal to replace all these 8 validators and slash their entire stake, right? And then the stake, which is in form of Ethereum, USDC, and partially deBridge token, will be reimbursed to those who had financial loss due to your collusion. And then these 8 validators will be replaced by someone who is more reliable and who is like posting their own like personal collateral as well. That's how the attack on the consensus layer is prevented. And that's why validators does not have any incentive to collude, because the profit is very limited. Like the profit is limited by the transactions that are being settled at this specific moment, right? But the loss of validators is not limited. Like it's their entire stake that is taken, the delegated staking and slashing module right now. But here it's also important to understand, like in order to make this model work, it's really important to understand to have some kind of zero TVL design of the value transfer layer. Because we started to talk a bit about DLN, and I wanted just like to explain a bit more of how it really works, because like in deBridge, we are actually the only team in the space that is trying to propagate this idea that like bridges don't need to have liquidity. Because like even if a bridge itself is secure, then there is a risk of ecosystem level hacks, right? There is a huge systemic risk. And let's say we've already seen this kind of hacks. We saw the kind of critical vulnerability found by Saurik in Optimism last year. We've seen the hack in the BNB chain ecosystem, where the attacker managed to mint like $6 million of bad liquidity. In this case, like the attackers can like simply transfer liquidity to other chains and leave LPs of liquidity pools of the bridges with bad liquidity on hand. That's why we are saying like, look, any bridge that has like TVA is not secure, because like the liquidity providers bear systemic risk. And we're taking completely different approach in terms of the value transfer layer. We are saying that like value transfer bridges does not need to have the liquidity pools, and there should be way more efficient model. Because like historically, all the bridges have been built as liquidity protocols, right? Where all the transfers are channeled through the shared liquidity pool. So you put the asset in the liquidity pool in one chain, and you take the asset like from the liquidity pool in another chain. But this kind of model has a set of fundamental flaws, because first, the amount of transfer is always limited by the amount of liquidity in the pool. Second, there is an on-chain price discovery, because any liquidity pool assumes AMM model. AMM model is needed for synchronous composability, right? For price discovery within one chain. But interoperability or like cross-chain space is asynchronous by default. And there is a way to avoid use of the AMMs, because we can build asynchronous protocols on top of asynchronous infrastructure. But like with classical bridges, whenever you have AMM, due to the presence of liquidity in the liquidity pool, you have slippage. And that's why users, they don't trade, they actually swap, right? Because the word swap assumes that you don't know the price at which trade will be executed. The best thing that you can do is to specify like slippage tolerance parameter. That's why users incur like the unexpected kind of slippage, and they don't know the price in advance. And third problem here is the capital efficiency. And it's like the really big issue, because so far there's no single profitable bridge. Like all the liquidity mining rewards that bridges pay always exceed profits that protocols collect. And the big part of this problem is that there is no way to manage liquidity efficiently. Let's say we have sound supported blockchains, right? And we have liquidity in liquidity pools in every single chain. But this liquidity is always limited by the kind of scale of the liquidity mining campaign. And at the same time, liquidity cannot be managed because it's like locked statically. And the transfers between chains are quite random. Like today we can have a huge flow of transfers from Polygon to Arbitrum. And tomorrow users will do a lot of trades like from Avalanche to Solana. And all these trades are like limited by this like liquidity pools, right? So there is no single scalable solution right now, and there is no capital efficient solution. Let's say if some big consumer app like Binance or like even OneInch will want to enable cross-chain trading in their app, they will not able to do that because there is no single app, there is no single value transfer bridge now that could process like $100 million or hundreds, like few hundreds $1 million per day, just because there is no liquidity. And the liquidity pool will always be the bottleneck. And in addition to that, as I mentioned, there is a huge systemic risk as well. So we are taking a completely different approach. And instead of bridging or like using locked liquidity, we are taking like liquidity in time or liquidity on demand approach, because we are saying like, look, like bridges don't need to have liquidity, but because it's needed only during the moment when settlement should happen. And that's why instead of using like liquidity that is locked statically in the pool, we can just attract liquidity from the market at the moment of settlement. And we
I quite like this design. Like the mental model that I have for this, and correct me if I'm wrong, is most bridges use AMM style, like Uniswap. You lock in a bunch of tokens, you keep it there forever, and that's the liquidity that can flow through the bridge. Essentially what you guys are doing is kind of like a on-chain order book, like a cross-chain order book where each transaction has a matching. So the liquidity providers of the bridge don't have to lock up their funds, which helps with three things. One is the fact of capital efficiency. Maybe they don't want to leave that liquidity there forever. The second is validators, or like if there's a bridge hack, you can't steal all of this locked up funds. Right. And then the third one is also the amount of liquidity that could be available because, well, one.
Yeah, exactly. Capital efficiency, scalability, and security.
And you don't need incentives, I guess, like to distribute some token to incentivize people to lock the liquidity when you're bootstrapping, for instance, a new chain. I mean, you can, of course, like just put money in a liquidity pool without incentives, but I mean, that's not.
Yeah, exactly.
There are a lot of risks, but yeah. Okay.
Because with classical bridges, you may not have any transfers during the day, but you still pay liquidity rewards because you have APY in liquidity pools. And you have zero transfer and you still dilute your token, right? And the model cannot be capital efficient. That's why there is no single profitable bridge. In our case, we like in DLN, have this liquidity in time approach. So we're switching the paradigm from the liquidity-based model to the liquidity network model. And like any transfer is channeled through the liquidity network that consists of two types of network participants, makers and takers. So maker is any on-chain address that wants to perform the trade. That can be protocol like Aave, or that can be like externally owned account or like EOA, so-called EOA address. And the maker just creates the limit order Like any trade is a limit order, where I'm saying, and I specify all the parameters of the order. I set up the quote for the trade, and I set the address of the token that I want to receive. So as an example, I can set the limit order to sell 1,000 USDC on Ethereum for 990 USDC, let's say on Solana. So I'm saying, look, guys, anyone on the market who will give me 990 USDC on Solana will be able to receive 1,000 USDC on Ethereum, right? And I don't need to have incentive. I set up the spread for the taker because this 10 USDC difference is the reward that I provide to anyone who will fulfill my order. And as soon as I post this limit order, and I can do that in two ways. First, in a guestless way, where I just provide the signature. It's just like the order in the order book, right? In the off-chain order book. Or I can set this order on-chain by locking my 1,000 USDC temporarily in the smart contract. Then it's like on-chain limit order. And then the entire market, like all the takers, can track this order and fulfill it. And the first one that provides me with the liquidity in Solana will trigger a message in the smart contract that is sent to the source chain. And this message confirms the fulfillment of the specific limit order and will unlock liquidity directly to the taker's address. So it's like purely peer-to-peer model. There is no any intermediary liquidity pool. Like maker provides asset in one chain, taker provides liquidity on another, and immediately unlocks liquidity in the source chain. So, and with this design, we have a couple of huge advantages. First is the infinite liquidity. Like the maker can create like $50 million limit order in a single transaction, right? And then takers can partially fulfill this limit order like until it's fulfilled in full. Second big advantage here is the capital efficiency, because like takers earn fee from the spread. They don't need to like lock liquidity. They always keep possession over their own liquidity. They hold it like in their wallet or like even a safe account, and they fulfill the limit order only if it's profitable for them and only if they decide to fulfill it. So the capital efficiency, scalability, and security is another thing, because like with this design, your liquidity is locked only during the very short time period when settlement happens. So protocol like basically has like zero TVA. And if you have zero TVA, then there is nothing to hack, right? It's like the whole attack
surface. That's a very cool part also for like, for scaling the liquidity available, right? Market makers might not want to sit in a volatile asset, like even Ethereum, right? And if someone's sending, let's say USDC to Ethereum, they could actually hold the USDC on the other side, do atomic swap to ETH, send that over, and then they don't bear the risk of actually sitting in a illiquid, or not illiquid, but a volatile asset. Then they get fulfilled back the USDC or Solana, whatever ends up being, and they can again, that time not atomically, but they can swap it back into an asset that they feel comfortable with.
Yeah, and that's exactly actually what we do. So let's say there are some like very liquid assets, right? Such as like USDC, USDT, ETH, and so on. But like if the maker wants to swap some altcoin or like not that liquid asset, then the takers may not be willing to fulfill this limit order because they don't want to bear the price volatility risks. As an example, you may swap, let's say, Cake token on BNB chain for Link token on Ethereum. And if takers do not hold Cake and Link on their balance sheet, then they will not be incentivized to fulfill the limit order. And our API knows like the kind of the balance sheet of the takers because like they broadcast their interest. And if you swap like between altcoins, then what we do, we like your transaction will pre-swap your altcoin, let's say Cake, into USDC. And in the same transaction, you will create a DLN limit order from USDC to Link. And as soon as limit order is created, takers will track it. And takers have USDC, let's say, on their balance sheet. And in one transaction, they will swap from USDC to Link through 1inch and fulfill your limit order at the same transaction. So actually, takers don't bear any risks. They provide USDC and they unlock USDC, even though the limit order was into the Link token. And that's quite interesting because like DLN is some kind of global liquidity engine where we can aggregate liquidity from the entire market. And if you create like really huge limit order and there is no enough balance on taker's balance sheet, they still will be able to partially fulfill your order in one chain, then unlock liquidity on another chain, rebalance that liquidity back through centralized exchanges and fulfill it again. But as soon as there is some incentive for takers, like the entire liquidity from the market will kind of flow toward this incentive. And with this design, not only professional market makers, like private market makers, can fulfill limit orders. The taker can be a protocol, such as Aave or Compound, because like the goal of the liquidity protocols is to monetize their locked liquidity, right? And they can get additional monetization channel by taking limit orders, by fulfilling them. And let's say Aave, they have like huge liquidity pools like in different chains, and they can, instead of providing like credit line to bridges, they wanted to do like with the portal concept. Instead of that, they can just like fulfill specific orders without the need to lock liquidity or bear like additional systemic risk. So yeah, and most likely all the limit orders will be fulfilled, especially like orders up to like a few $1 million will be fulfilled by takers very quickly. But like the bigger orders can be fulfilled by the liquidity protocols. And another thing that I wanted to highlight here, the speed of settlement, because in DLN, limit order is fulfilled almost instantly because takers don't need to wait for guaranteed finality. Because like actually takers are those who bear the risk of transaction finality. And if there is a limit order, they can say like, I will fulfill the limit order after one block confirmation in Polygon. And then they provide liquidity on another chain and unlock liquidity on Polygon, but they bear the risk of like reworks. But the interesting thing here that like in case of gasless orders, they can rebroadcast their own transaction because they are those who execute transaction on behalf of the user in the source chain and immediately fulfill on the destination chain. And if there is a rework, they just replay or like rebroadcast their own transaction. So with DLN, users don't need to wait for like 15 minutes or like 10 minutes. They're like almost any trade is fulfilled very quickly. So the user experience is very similar to the one that the users have on the centralized exchanges.
Okay. I would like to take a little bit more, take some distance from DLN and its design, and have your opinion when it comes to like other, let's say, architectures and designs to set up bridges. Let's say we hear more and more about light client bridges, zkbridges, like all sorts of
ZK light client bridges.
ZK light client bridges, and so on. I said optimistic already. And as a bridge or I should say a bridge designer, I wanted to have your take on some of these bridges, which sometimes might claim that they are the future of cross-chain messaging whatsoever. What would be your take on these designs? Do you plan to actually implement some components from these architectures in future iterations of DLN, or you see them as flawed in a certain way? I would be curious to have your opinion on this, Alex, and also you, Daniel.
I can start, Daniel. Feel free to add other points, but I think that there is a lot of marketing in this space, and sometimes marketing kind of outweigh the technological component, because people are saying okay, we are now doing zkBridge, which is way more secure. But again, I truly believe that optimistic component or ZK approach does not add security to non-canonical bridges. Because again, in non-canonical bridges, you have the consensus layer, you have validators. And validators can forge any sort of proofs. They can forge ZK proof, or they can forge the block header. So any sophisticated additional validation does not add any security. It adds more on marketing, but moreover, it adds additional gas overhead. So this kind of using ZK makes sense for canonical bridges, and I think Saxon is doing interesting stuff. Just yesterday, they announced the kind of the way to validate the Ethereum consensus on other chains. But again, this is canonical validation, and it works only in the one way, where another chain you can validate the consensus in Ethereum. But you will not be able to validate consensus of other chains in Ethereum, because it's very expensive operation. But again, the goal of this ZK research and other sophisticated validation mechanics is to enable more efficiency for canonical bridges. For non-canonical bridges or for interoperability solutions, it does not make any sense. I've been talking to many different VCs and people recently, and people don't really understand sometimes how the bridges are different, and that canonical ones solving completely different problem, and non-canonical ones always have the validation layer and also mainly solve for information transfer. And again, I truly believe that for example, optimistic approach is not really secure at all. And just I see that many people are excited, but at the same time, in optimistic approach, you still have validators or watchdogs, right? And they, even if the one watchdog is malicious, then it can censor all the transactions. And still everyone can collude in order to forge the message. It's just it does not add any security. It just add additional kind of complexity for the end user, because optimistic design adds additional time for the message validation. So yeah, I really think
I would defend optimistic a little bit on that. It is a one of n security assumption, though. We were talking about zk client bridges, so this is changing a bit, but it is you only need one honest relayer. That's the difference of an optimistic design compared to a multi-sig. Instead of having whatever threshold of signatures, you just need one honest one.
Exactly, or you need one,
which the user could be one
everything.
You would have to censor the whole chain at that point.
But if you open the watchdog position to a broad network of watchdogs, and you just need one out of n to be honest, it's not that bad, right?
No? Yeah, that's a good security assumption. I quite like also for zk client bridges, you need essentially. Okay, there's two important things for zk client bridges. One is cross-chain from Solana to Ethereum, and one is multi-chain from Arbitrum to Optimism. And in the case of multi-chain designs, you can make it quite trustless. There will be an increased latency though. So you can actually create a proof of the state of Arbitrum, send it through the native bridge from L2 to L1. Maybe Arbitrum's the wrong example because that has a 7-day delay. ZK would be better for this, but you get the point. You can send it through the native bridge down to L1 and then trigger the second L2 bridge up to Optimism natively through L1, and you don't need any external relayers for that. And you can verify where it came from and how the proof was created. So you do have a fully trustless solution as far as going from L2 to L2. Of course, that still takes into consideration reorgs and latency. So you do need to still wait for those chains to settle and create proofs. And the truth of it is most zk client bridges will probably not use the native bridges. In fact, I don't know a single one that does it because it's a lot of delay, right? They will do direct L2 to L2, at which point there is some trust assumptions. Of course, the difference is that the sync committee of Ethereum on those L2s, so it improves it a little. I won't go into that. But you do start having some of the external security assumptions that you do with zk cross-chain client bridges. And for the watchers that don't know, essentially, zk client just allows you to take the latest block headers. So, for example, at this point, Daniel has 10 ETH. And at this point, Daniel sent 10 ETH to this contract instead of having to sync the entire chain. And this way you can submit the latest state of a blockchain onto another blockchain without having to have the entire other blockchain run inside of it. So it is a lot better than a lot of current approaches because you can verify through a smart contract called the state of the other chain. But the issue again with the multi-chain, for example, is in order to check the BLS signatures of that state, you need to know who the actual validators were on the other chain. And at that point, you start needing external relayers to submit who were the validators and to be able to have that chain and verify that this is a correct state, that this wasn't a fake Solana state submitted onto Ethereum. So at that point, yeah, you do start having trust assumptions again. I would advocate for optimistic and zk-like client bridges, though they are quite clean, and they do improve some security guarantees. But you are right in the fact that you still do need, it's a lot of increased technical complexity, which could create its own security issues, right? And right now it does take a while to prove it, so it adds latency. But I think with time, as time goes by, for ZK, we'll improve the algorithms for actually creating the proof. We can do GPU acceleration, and those will get more and more efficient. And the black magic math that ZK will be tested more with over time, especially
there's
with
risk. You need to trust the prover, and you need quite some time in production and a lot of money that goes through these systems before actually, I guess, trusting them. Where in the case of optimistic systems, it's a bit more primitive, straightforward. Like there's less math involved, right?
It just adds latency. Like it might add 30 minutes latency in order to have enough time for the watchers to be able to actually make a contesting transaction. Otherwise, someone could come and essentially clog up the chain for 5 minutes, and then no one could afford to submit a contesting transaction. So the longer the time you wait in an optimistic system is safer. Like they'll never be able to lie ever, but you might be able to block the watcher from submitting that contest.
Exactly. But again, I never said that like I don't like ZK Light Client or like I'm going against of the optimistic bridges. What I'm saying is that ZK Light Client bridges and optimistic bridges make sense for canonical bridges, but it does not make sense for interoperability solutions. Because like for interoperability solution, when I do the transfer, I want to have my transfer settled immediately, right? Or I want to have my message settled immediately. And let's say in the case of DLN, I want to do a trade and I want to receive the asset. And all the complexities, like takers will be those who will use canonical bridges, and takers will be those who will have to wait for like optimistic time period or like relay or use like ZK Light Client. But as a user, already like enjoy the user experience. I already did a transfer in a truly secure and trust minimized way. And like ZK Light Client is something that I'm also like really excited about, and we'll see how the overall like development will unfold. But I really think that like it more makes sense for like canonical bridges which are solving for asset custody. First of all, they're solving for like the challenges where risks are born continuously in time, like in asset custody case. But for all other cases, we may have like interoperability solutions, which are not like decentralized. Again, they bear these risks of the consensus participants collusion, but at the same time, they provide like financial guarantee. And that's like our goal in, for example, in deBridge specifically, like to enable this like seamless and secure interoperability. But like, I'm also very excited about how the space of the canonical bridging evolves. But it's very important to understand this difference, because many people are assuming different things under the word bridge. Some people are thinking that is like wrapping and minting of the assets. Some people are thinking that it's like using canonical bridges. Some people are thinking that it's like the swapping. But yeah, it's like very different. Like two main categories are like canonical and non-canonical bridges, and then like non-canonical are split into different groups depending on how their validation layer is designed. But again, yeah, this space is quite like is really exciting, and we've seen many good and bad things here. But I truly believe that like it's really possible to build secure solutions, and like the cross-chain infrastructure is something that is very much needed, because like at the end of the day, even classical markets will be gradually moving on-chain, just because the settlement like on-chain is way more efficient. It allows to avoid different intermediaries. And we already see different like parallel execution environments such as like Solana, Aptos, and Sui. But like so far, there is no single cross-chain infrastructure that would kind of build the capital efficient and secure economy simultaneously. And there is no single scalable solution. And I believe that like the first team that will manage to figure out how to build this like scalable and capital efficient solution will be able to take the good part of the market opportunity.
I do think that we'll have some more scalable solutions through L2s and sharding dApp state with shared sequencers, and some other very exciting developments that are happening. Like I've always been a grumpy programmer. Like I've been in crypto for a long time, but I always had the skepticism of this shit doesn't scale. Right. The reality is like there are some really exciting new developments in the L2, L3 space that could actually allow some sort of dynamic load balancing. But I still don't think that's gonna forever remove like us using also cross-chain, right? And we will need those solutions in place. And I think it's really important for us to design very secure systems. And I do think it's possible that with time, like security is a function of time times money, right? How much money is there and how long has it been tested for? So I think they will keep getting safer and safer, even if I recommend to stay on Ethereum. I do think that we can get bridges to a much safer port than they have been historically.
And
yeah, we'll see. We are working on that at least actively. And, yeah, I think within the next 1 or 2 years, we'll see like many interesting secure cross-chain apps that are already like built on top of bridges, and bridges themselves will already like empower all these transfers of information and liquidity. Because Ethereum is great, like Ethereum is the most secure ecosystem, right? But like security comes at cost, and many guys who have not been in the Ethereum community from the beginning, they cannot afford this cost. That's why we see like all this interoperability solutions.
L2s, L3s. We'll get it to pennies, don't you worry.
Exactly, and it's quite interesting because like very soon we'll be able to deploy the roll-up like in a single transaction. We just click the button and we get like scalability solution. It's like with Amazon Web Services, right? If we need to scale up like something, we just like can enable auto scaling, and like Amazon will kind of automatically allocate the resources to us. Something
and then your
similar
bill will
now
kill you. And then the bill comes. And then the bill comes.
Yeah, then the bill comes. Absolutely, yeah. Same here. And our goal, like we provide the infrastructure so that like in cross-chain we also like issue the bill for those who want to scale to all other layer 2s or like all other chains. And for us, like the more blockchains we have, the better for like cross-chain infrastructure, of course. But yeah, again, we definitely need to have this like secure intercommunication channel. And at the end of the day, like we'll see more and more apps that are moving like from the centralized infrastructure providers on chain to have like the reliable and trustless kind of environment where the app logic should be executed.
Yeah, and bouncing back for a last time on security, there is a bounty on Immune5 for whoever manages to find any kind of vulnerability in your system, right?
Yeah, exactly.
Yeah.
So in deBridge, like we treat security very seriously, and that comes not only to security audits and Immune5 bug bounty program, it comes to overall protocol design. So we started to think about security when nobody talked about bridges. It was like in the beginning of 2021, right? And we laid various security measures in the protocol design itself. And let's say that comes to deBridge node and like to overall design of the deBridge smart contracts. But in addition, and I outlined like all these measures in one of the articles that we published in our blog. But like in addition to that, like we passed like really many security audits. deBridge has been audited like 18 times, and we audit not only like smart contracts, but every single line of code that we produce. And that comes to deBridge node, like all the APIs, and even like the website we have. And yeah, kudos to all our security partners who have been helping us on this journey, because like in cross-chain space, you have no chance to make mistake. And you can build the great technology, right? You can have traction. But if you make one single mistake, then like all gone. And that's why like security is very important.
There's always bugs in code. Always.
Yeah.
Like
because security is a Swiss cheese.
I don't think I've ever written a program that didn't have a bug in it.
It's funny because you have this trust the code, you know, like it's trust minimized because code is low and you gotta trust the code. But yeah, once the code is actually beyond like 500 lines, you gotta trust the programmer.
Yeah, and the goal of programmer and the goal of the team is to minimize the chance of bug, right? Because security is some kind of Swiss cheese model. You have the cheese which is sliced to different pieces, and every piece has like holes. And your goal is to make sure that these holes never aligned, so that attack can be performed. But again, like it comes not only to security audits, but also to design itself. And that's why we are so excited about DLN, because DLN is the protocol with like zero TVL, which actually solves the problem of the capital efficient cross-chain transfers. So yeah, it's just like cross-chain is quite different. It's quite difficult because there are so many components involved. You not only build DeFi protocol, but you also have infrastructure, you have like validators, and it's quite difficult to assemble this puzzle correctly, but it's still possible. And like we are trying to prove that together with the team and many other teams who are building in this space.
Pretty cool. What would be the best ways to engage with both of you guys and connect?
Daniel, you go first.
You can find me on Twitter at zkbridges. I post random shit there sometimes. Mostly I'm heads down researching, but I have been making more of an effort on Twitter to publish some of that work as well. So follow me on Twitter.
Yeah, same for me. You can find me on Twitter or Telegram. On Twitter, you can find deBridge, deBridge Finance, and like deBridge Finance is following my account as well. And yeah, like we're on any social network. DMs are open. Always happy to have like interesting and fruitful discussions about like security, cross-chain space, and so on. And yeah, I really also think that like it's very important to work on educating people about the like cross-chain space and about the DeFi in general. And yeah, I think that you guys are doing a great job in this regards. And yeah, I hope that this episode will be also useful for some members of the Web3 community, like to better understand the overall approach and the concept of how cross-chain infrastructures can be designed.
Hoping so too. And as usual, I'll leave all the relevant links in the description. If you have any comments, feel free to share it. If you like the content, feel free to subscribe to the channel. And yeah, I'll thank both of you again. It's been really a great pleasure to have you on the show. And I'll see everyone pretty soon.
Thank you, guys. It was great chatting.
Cheers, guys.